Last class we have seen what is the formula applicable to calculate the work done by the shell. That is given by the equation W max is equal to NF E naught. This is the maximum work done by this. Then what is the free energy change during the net electrochemical shell reaction? Delta G is not equal to minus NF E naught because delta G naught is equal to the W maximum. Then if you are given the relation, then delta G should be NF 0 only. Why it is not minus? It is Y minus because the work done by the system and by convention, we take the W as the minus value. Therefore, delta G is equal to minus NF E naught. And this is an electrochemical parameter and this is a thermodynamic parameter. And if you want any electrochemical parameter to convert into thermodynamic parameter, you should go by this equation. You have finished this one. This is for the parameter in the standard state. Is there any equation for calculating the delta G in a non-standard condition? Yes, it is available. We simply throw out the not in the superscript, you will get the equation. Then, but you will be given the E naught. You are asked to calculate the E. E naught is the shell in the non-L EMF in the standard condition. E is the cell EMF other than the standard condition. There is a relation. That relation is derived by a Walther Nernst, and we call it the Nernst equation. First, we will work out some problem in this one, delta G0 is equal to NF E naught. Then we will go for this. And after finding out delta G0, you can calculate delta S0 entropy, standard entropy change as NF into, what is the formula? NF into dou E by dou T. What is dou E by dou T? That is at constant pressure, partial derivation, difference in the EMF of the cell at two different temperature, and dt is the temperature difference between the two conditions at constant pressure. This parameter we call it as the temperature coefficient of the shell EMF. What do you mean by temperature coefficient of shell EMF? That is change in the EMF value per 1 degree change, 1 degree change in the temperature. That we call as the temperature coefficient. And another equation we have derived is that delta H naught can be calculated using the equation NFT into dou E by dou T at constant pressure minus NF E. That is E naught. This is the equation. Making use of this equation, first we will work out some problem. Then we will go for the next problem. And first we will analyze the formula. This delta G is equal to minus NF E naught. What are the possible problems that may be asked in making use of this equation? E naught is a variable and F Faraday is a constant. N, the number of electrons involved, the total number of electrons involved in the chemical electrochemical reaction. It is depending upon the electrochemical reaction, it is going on changing. Accordingly, delta G will be also changing. Therefore, three kinds of problems may be asked in this session. What are the three kinds of problems? First, you take down the first problem, then we will go for the next one. Take down the first problem. The EMF of the standard Western cell, written as cadmium amalgam dipped in cadmium sulfate, solid 8 by 4, 8 by 3, H2O solid, and with a salt bridge cadmium sulfate saturated solution in which mercury sulfate is added in the solid state and mercury liquid is acting as a cathode. Where cadmium mercury amalgam is acting as the anode is a western cell with a cell reaction. With a cell reaction, cadmium amalgam plus mercury sulfate is solid as the another reactant plus 8 by 3 H2O liquid as the product, giving cadmium sulfate 8 by 3 H2O solid. This is the product uptime plus 2 mercury liquid. And this is called the overall cell reaction. The EMF for the cell is 1.02 volt. 1.02 volt. Here for the cell, the standard cell at 25 degrees centigrade. At 25 degrees centigrade. Here, whether the 1.02 volt given is a standard EMF cell or it is other than this one. Here, there is no mentioning about this. They just give it as the EMF, but it should be a standard one. How you have arrived at the standard one? Temperature is given, okay. And the electrolyte concentration should be 1 molar, 1 molar. We have studied. Here the electrolyte is mercuric sulfate and cadmium sulfate. They are in the solid state or solid state. The activity for a pure liquid or a pure solid, the activity is taken to be unity you have studied. Therefore, here the cell EMF given is standard EMF, E naught. In this way, you can say whether the cell EMF is the standard condition or the non-standard condition. It is a standard condition. E naught is given. Then you may be asked to calculate. Now calculate delta G0, delta S0, and delta H0, and delta H0 for the cell reaction. For the cell reaction. If dou of E by dou T at constant pressure is constant pressure for the cell is 5 into 10 power minus 4 volt per Kelvin. That is so much voltage change per 1 degree change in the temperature. Okay, this is a direct question. It is not asked in the says here, but using this, how you can calculate this one, then we will go for says here questions. Now you are asked to calculate delta G0. Delta G0 is equal to minus NF E naught. E naught is given. F you know. N you are not knowing this, but the cell reaction is given. From the cell, you have to calculate the total number of electrons involved. Cell reaction, you have to calculate the total number of electrons. Either you can take the oxidation of the cadmium solid, cadmium mercury. Here in any mercury, in a solid state, the cadmium is in zero state. But in the substance, here cadmium is in which oxidation state? +2 oxidation state, because sulfate is having 2 minus, cadmium is +2. That in this process, 2 electrons are involved. That is sufficient. Or you can take the reduction process, mercuric sulfate converted into mercury. Here, mercuric sulfate is equal to the oxidation state. Sulfate is 2 minus, therefore mercury is the 2 plus state. It is converted to 0 state, therefore how many electrons are involved? 2 electrons are involved. Therefore, in this cell reaction, 2 electrons are involved. The N value they won't give you at all. You have to calculate in this way. Therefore, minus 2 into F is equal to 96,500 into E is equal to 1.02. Multiply with your own calculator. That is minus 2 into 9.6 or 9.7 into 10 power 4 into 1. You can make it 1. Therefore, 2 into 9.7. What would be the value? Tell me the value. Approximate calculation method. The value is nearly minus 194 into, I'm sorry, 19.4 into 10 power 4 joule. Why it is joule? N is merely a number. F is nothing but coulomb. Electron volt is nothing but 1 joule per coulomb. With coulomb and coulomb cancelled, therefore the net unit is joule. Therefore, now you are having the value minus 195 kilojoule. 10 power 3 can be written as 10 power 3 joule is equal to kilo, and that 10 power 1 remaining is added to this, and you are getting the value minus 194 kilojoule. This is the way, and you can come across, you can see the option which is very near to 190 minus 190 very in this way you can calculate the delta. Another is if delta G0 is given E0, then they may ask what number of electrons involved in the process. Okay, we see one by one in this section. Now you are asked to calculate delta S. What is the equation for delta S? Delta S is equal to NF into the only when temperature coefficients given, you can calculate this. And the temperature is directly given to you. The value is equal to the value given is 5 into 10 power minus 4. Or in some other way, they may be giving the electron still take two different temperatures. And if it is given in two different temperatures, you can calculate the dou E by dou T. Then apply this one. Now we will calculate the delta S is equal, not is equal to 2 number of electrons 2 into 9.7 into 10 power 4 into this number coefficient 5 into 10 power minus 4, okay, and is equal to என்ன கிடைக்கும் பெருக்குங்க பெருக்கி சொல்லுங்க, making use of your own calculator. Making use of your own calculator. What is the value? Tell me the answer.
291.
291. 97. That is the correct answer. Why it is 97? What is 9.7 into 10 power 4? And that's 10 power 4. Or cancelling is not. 5 into 2, 10. 10 into 9.7, 97. What is the unit for this? What is the unit for this? Anybody? It is merely a number and it is a coulomb. 5 to 10 power minus 4 is nothing but volt per Kelvin,
Kelvin.
and volt is nothing but joule per coulomb
Joule Kelvin
Kelvin.
inverse.
Yeah, joule per Kelvin. This is the unit for this entropy change for the cell reaction. And another is given is delta H naught. What is it? Delta H naught. The delta H naught can be calculated in two ways. One way we have given a direct problem. That is delta H is not is equal to delta H is not is equal to this way. And delta, or there is another method by which you can easily calculate. What is the method? You have, I'm sorry,
Sir, 485.
485.
Yes.
No, delta H naught is equal to, or you know this equation, delta G naught is equal to delta H naught minus T delta S. Since we have calculated delta S and delta G naught, you can calculate delta H naught. And the value for delta G naught is minus 194 kilojoules. And you are going to calculate where the delta H minus T into, and delta S is T is equal to the temperature 25 degrees C is given, therefore 298 into delta S is 97 divided by 1000. Why we have given this 97 divided by 1000? Anybody? Anybody?
It's Joule, I
Kilojoule
believe.
converted into joule.
Here it is a kilojoule, therefore joule should be converted into. Here you may do an error, and the 298 can be simply converted into 300. This and this cancel. This 97 may also be converted into, say, 97 may be also converted into 100, or you can make use of this 300 into 100 by 1000. This and this cancel, and this 30. Therefore, x is equal to, bring it in the other side, you will get plus and 4, 6, 1 minus 164 kilojoule. So much amount of energy is, heat energy is released, x is equal to. You can easily calculate it this way. Suppose you are given E naught and the temperature coefficient of the voltage dot T at B, you have to first calculate delta G, then calculate delta S, then you have to calculate delta H. Instead of going like this, directly apply the equation. Delta H is equal to N F T into dou E by dou T minus NF E naught. In this case, you can easily calculate directly. Therefore, I have given this one. But if you calculate delta G and delta S, you go by this equation. Or whatever may be the method you are following, you will get this one. Okay. Now take down the problem and you work out what is the correct answer for this. Take down the problem for this reaction. For the reaction, 3Ni2 plus 2CrOH thrice solid plus 10 OH minus aqueous, giving 3 nickel solid plus 2CrO4, 2 minus aqueous plus 8H2O liquid. Delta G naught is equal to 87 kilojoule per mole. 87 kilojoule per mole. Well, sir, given the standard reduction potential, of nickel 2 plus minus minus 0.28 volt, comma, what is the standard reduction potential? Standard reduction potential of the half reaction CrO4 minus aqueous plus 4H2O liquid plus 3 electron giving CrOH thrice solid plus 5OH minus aqueous question mark. Option A minus 0.43 volt, B minus 0.28 volt, C 0.02 volt, D minus 0.13 volt, E minus 0.15 volt. I think this type of problem, whether it's asked in the CSIR examination, I don't know. But it is somewhat a next difficulty level. It is not a direct problem. They're one step ahead you have to go from this. Here, for the cell reaction, this cell reaction, what is the cell reaction? This is a cell reaction. For this cell reaction, you are given the delta G value. And the delta G value from which you are asked to calculate what is the standard reduction potential. Therefore, there should be a relationship between the delta G and the potential. What is that? I have already told that delta G naught is equal to minus NF E naught. Delta G is given. N is not given, but you have to derive what is the value of N in this net from the net reaction. You can calculate easily. From this, you can calculate E naught. What is E naught? The cell EMF. The cell EMF is given as E cell is equal to the oxidation potential of the cathode plus the reduction potential of oxidation potential of anode plus reduction potential of cathode அப்படின்னு படிச்சிருப்போம். மாத்தி படிச்சோமா? The page has been gone. You will once again write it one. What this we have written? The delta G naught is equal to minus NF E naught. First we will work out this problem for getting the value of E naught. Then how to approach the problem. But E naught is not asked. You are asked to calculate the standard reduction potential for a half reaction is asked. Therefore, it is a two-stage problem. Therefore, I have told you that it is not a direct problem. First, you calculate the delta G is given, and then if you know the number of electron, you can calculate E naught, is not? What is the delta G given? 87 kilojoules. Here, you should not use the kilojoules as itself because when you multiply the F and E naught, you will get the value only in the joule, not in the kilojoules. Therefore, instead of delta G in the kilojoule, you write it as 87,000 joule is equal to minus N, number of electrons involved in the process, in the reactions. I have told you, you can make use of any one of the oxidizing or the reduction. Here it is given Ni3 plus 2, Ni nickel 2 plus in the reactant side, product side it is given as Ni3Ni. What is the total oxidation number of this Na2 Na here? It is plus 6. That is, for 1 nickel it is plus 2. For 3 nickel it is plus 6. Here, for 1 nickel it is 0. For 3 nickel 0. Therefore, how many electrons are involved or how many electrons are consumed by the nickel 2 plus? 6 electrons are involved. Therefore, number of electrons involved in the process is 6 into 965,000 into E naught. Shall you calculate the E naught now? E naught is equal to, anybody, E naught is equal to how much? E naught is equal to how much? You can calculate. This and this cancel, this and this cancel. E naught is equal to என்ன வரும்? 870 divided by minus 6 into 965 or it can be written as 8.7 by 6 into 9.7 or simplifying it. You can convert in this 9.7 as a whole number as by increasing by 0.3. Similarly, here it should be, here it is proportionately almost to same. Therefore, you can make use of the 3 can be decreased 8.4. Then divide this and this. How you can, the 6 and 8.4, 1 divided by 1.24, you can make use of it as 4 and 10, therefore minus 0.14 volt. Therefore, E naught is equal to minus 1.4
Sir,
volt. Yeah.
sir, for division கீழே நம்ம இன்க்ரீஸ் பண்ணா மேலேயும் இன்க்ரீஸ் தானே சார் பண்ணுவோம்?
Yeah, I have forgotten. Thank you, ma. Thank you very much. Sorry. Thank you very much. 1.5 point minus 1.5 volt. Don't be as an in the situation like if you go this, there is an option is given, E option is minus 0.15. They are not asking the cell EM. They are asking you what is the half reduction potential. Therefore, next stage is E cell. You have found out the E cell is equal to E naught of the anode. What is the anode present here? Which is the anode present here? We have seen the nickel 2 plus giving nickel. It is a reduction process. Reduction process is taking place in the cathode. Therefore, here you have to write E is not is Ni nickel 2 plus for nickel. Therefore, in the anode, which reaction is taking place? CrOH, oxidation should be taking place. Oxidation is taking place. Chromium hydroxide is converted into chromate. This is the oxidation potential. E cell is minus 1.5 and this is X. E0 and this is given. What is given? The reduction potential is given. Here you are also in need of reduction potential. Therefore, 0.28 volt. A 0.28 volt. Therefore, what is the value of X? X is equal to bring this in the other side, you will get 0.13 volt. This is the oxidation potential of this half electrode. But what is asked? What is the standard reduction potential of the half reaction? Therefore, for standard reduction, this is the oxidation potential. What is the standard reduction potential? Minus 0.13 volt. Therefore, which is the correct option? D is the correct option. Therefore, this type of problem can be done very easily if you practice once again. You can easily do the problem. What is asked? Whether oxidation potential is asked, or what is oxidation potential is given, or reduction potential, that is very, very essential with respect to electrochemistry. Otherwise, you would be easily cheated. Because the answer may also be what you have calculated. This answer is also present, plus 0.13, it is not given. This may also be given as another option. This may be given another answer. Plus 0.15 volt may be given another answer. Whatever may be the error you are committing, and the erroneous answer would also be present as the distracted. Therefore, each and every word should be carefully read in the case of electrochemical reaction, because you can very easily cheated by this one. And shall we go for the next problem? Check on the problem. At 25 degrees centigrade, 25 degrees centigrade, for a cell, the EMF measured, for a cell, the EMF measured is, standard EMF measured is 0.3 volt. The 0.3 volt. The equilibrium constant of the cell reaction is found to be 10 power 10. Is found to be 10 power 10. Calculate the number of electrons involved in the process, cell reaction. Number of electrons involved in the cell process. This type of problem has been so far not asked in the following. Here E naught is given, equilibrium constant is given, N is asked. How to calculate this one? Yes, it can be calculated. How? Equilibrium constant is given. From the equilibrium constant, you can calculate this one. Equilibrium constant is given by the equation delta G naught is equal to minus 2.303 into RT into log K. This is the equilibrium constant. The equilibrium constant is given at standard condition. The K value is also an extensive property, is going on changing. And here you should calculate the equilibrium constant in a standard condition. Therefore, K can be calculated only from the delta G naught. But delta G naught can be calculated from E naught. Therefore, how in the place of the delta G naught, we are writing as NF E naught is equal to minus 2.303 RT into log K. Therefore, log K is equal to, what is the formula? NF E naught divided by 2.303 into R into T. Here in the standard condition, T is a constant, R is a constant. Yesterday I have told you the F is a constant, N into 96,000 coulombs into E naught in volt divided by 2.3 into 2.3 into R 8.3, 8.314 joule into temperature 298. These values are found to be a constant. This value is equal to 0.0592. This is the actual value. Therefore, here we have to written as n into E naught by 0.0592. For our simplicity, we convert into n E naught by 0.06, or according to our convention, 5.9 into 10 power minus 2. One decimal, one digit, one decimal conversion like this, or you can make use of this simple, once again simplify it, 0.06. Okay. Therefore, log K is equal to this equation. You can make use of this. Now, use this as a formula to calculate log K or K from E naught. Sometime the K value may be asked, but not in the numerical value, because it is given in 10 power something, it may be given. That also can be calculated. K is equal to, for bringing the logarithm in this, this one, it is becoming the anti-log. In such cases, K is equal to 10 power n E naught divided by 0.06. Therefore, look at the answers given in the distracted, either in the 10 power it is given, or it is given in the numerical value. If it is given in the numerical value, you have to take the anti-log with your own calculator. The anti-log, you can make use of that anti-log. You can calculate this one. Therefore, now I have derived an equation for a simplification method. If log K is given, use this equation as such. Log K is equal to this much. Do you follow this? Use this equation if log K is asked. On the other hand, if K is given in terms of this one, that is power of 10, you can make use of this equation. Okay, keep it in mind. Now we are going to work out our problems. We will do our problems. What is given? K value is given. K value is equal to 10 power 10. Then what is given? E naught is given. That is equal to, E naught is equal to how much? 0.3 volt. What is asked? How many electrons are involved? K and E naught relationship we have studied. Log K, that is log 10 power 10 is equal to N E naught 0.3 divided by 0.06. We have 10 power, log 10 power 10 is equal to 10, and this can be cancelled as within our own 0.02. Therefore, n is equal to 0.2, sorry, 0.2, I think so. 0.2, n is equal to 10 into 0.2 is equal to 2. Number of electrons involved in the process equal to 2. This type of problem so far not asked in our CSIR, this one. Okay, I think you understand this type of problem, and we will go for the next type of problem. And with that, we finish this discussion, then go for the Nernst equation. Take down the another problem. This is the problem is for the homework. Set up electrochemical shell. Set of electrochemical shell for the cell reaction. H2 gas plus Cl2 gas giving 2H plus aqueous, and calculate the equilibrium constant. Calculate the equilibrium constant for the reaction, comma, given this potential, electrode potential, E naught Cl2 bar Cl minus equal to 1.36 volt. And if you understand this, you can easily construct the cell. You looking at this. இதை பார்த்த உடனே எப்படி சொல்றதுன்னு I have already taught to you. The H plus HCl is present as H plus and Cl minus in aqueous solution. Therefore, looking this, you can easily give E naught of, sorry, epsilon naught of H2 bar H plus. That is electrode potential plus E naught of here reactant Cl2 bar Cl minus. Reactant should be written in the top and the product should be written in this. Here reactant is undergoing oxidation, therefore it is oxidation potential and it should be anode. Last class we have discussed this one. Here chlorine is zero oxidation state and is undergoing reduction. This is the cathode. And here E naught of this is given, but it is not given. You know, the standard electrode potential of hydrogen is zero. Therefore, now you can calculate what is E naught of the cell. E naught of the cell is equal to the E naught, this epsilon naught of the anode plus a reduction potential of the cathode. The reduction potential of cathode is given, therefore E cell is equal to, for hydrogen it is equal to 0. For chlorine it is 1.36 volt. E cell is given. You are asked to calculate K. In what manner they have given this K value in the answer. Whether it is a power of 10 is given, you write according to the power of 10. Or cell is given in this one. If it is given in the power, then 10 power n, number of electrons involved in the process is 2. And epsilon E cell is 1.36 divided by 0.06. Correct answer will be very near 2 because 5, 9 and 2 is the division. Here what is the value? This and this cancelled as 0.03. Is not? Then divide this 1.36 using the R, convert into 3 into 10 power minus 2, go up to this 10 power 2, 3 divided by this is you will get 0.4, 5, 3 into 10 power 2 equal to 10 power 45.3. The value should be definitely greater than 45.3. Why it is 10 for 45.3? Here we have written 0.06, but actually it is 0.592. Here the value, lower the value in the denominator, higher will be the answer. Therefore, but answer would be very nearer to this. The correct answer is 10 power 46. Therefore, by using this approximation method, you can calculate this one. And another very important, I told you that this is a homework for you, but I have worked out this one. Yeah.
Sir, அந்த E naught cell is equal to E naught H2 ன்னு இருக்குல்ல சார், அது ஒரு வாட்டி எக்ஸ்பிளைன் பண்ணுங்க சார்.
This epsilon.
E naught cell is equal to E naught H2 bar H plus anode cathode.
This one. This one.
Yes sir.
And this one.
Yes sir.
Or both.
Both.
Here, how I have constructed the cell. Here, the first question asked is, set up the electrochemical shell. Setup means represent the cell in terms of what we have written. Here, the one, according to the cell reaction, one should be an oxidant, another should be the reductant. Which is the oxidant? Oxidant would form the anode, and reductant would form the cathode. This already we have explained in the last 2 classes. Here, which is undergoing oxidation. Look out the reactant side, hydrogen, and what about the hydrogen in the product side? Here, hydrogen is in the zero oxidation state. Hydrogen in the zero oxidation state. Here the product side hydrogen is in +1 oxidation state. Therefore, hydrogen is undergoing oxidation. The oxidation would form the anode. Therefore, the anode I have written is epsilon. Epsilon is the electrode potential symbol for hydrogen, the reactant H2 reactant. It is converted into H plus, bar H plus, because it is present as H plus. It is anode. If it is anode, the other reactant should be undergoing reduction. It is chlorine 0 state. Here chlorine is the -1, it is reduction. Therefore, epsilon 0, the reactant above the bar and the product below the bar. And it is called cathode. Here you should know the reduction potential. Here you should know the oxidation potential. The reduction potential of the cathode is given as 1.36, but they have not given the oxidation potential of this anode, because you will well know the oxidation potential of the anode, hydrogen for H plus is taken to be 0 for our case. Therefore, I have put 0 and the reduction potential is plus 1.6. Therefore, this and this will give you the cell EMF. Knowing the cell EMF, you can calculate the K. Okay?
Sir, E cell is equal to E anode minus E chemistry.
Yeah, that is another formula. அது எப்படி கொடுத்திருப்பாங்கன்னா E naught of reduction oxidation potential of anode minus oxidation potential of cathode. E cell is equal to this size. Oxidation potential of anode, oxidation எழுதினீங்கன்னா இப்படித்தான் வரும். Instead, here I am not writing this is the oxidation potential, and I want to know the reduction potential. Sum of these two அப்படின்னு போட்டு நான் இங்க பிளஸ் போட்டிருக்கேன் என்னுடைய வழியில. ரெண்டு ஆக்சிடேஷன் பொட்டன்ஷியல் கொடுத்தாங்கன்னா you go by like this. Okay. Instead, there is a book in which E naught of reduction potential of cathode minus reduction potential of anode. இப்படியே சில புக்ல போடுவாங்க. These are all leading to confusion to you. Therefore, I want you to follow the oxidation potential value. Anode oxidation போட்டீங்க. இங்கே oxidation potential தான் போட்டீங்கன்னா minus of oxidation இப்படி எழுதணும். But here which process is taking place? Reduction is taking place. Or simply convert into reduction, just to plus it. Or now we are going to use this oxidation potential of hydrogen is minus. What is oxidation potential of the cathode? Here reduction potential is given. What is this oxidation potential? Minus of 1.36. Now you put this as minus of 1.36. This minus and this minus cancels 1 into plus. You will end up with once again this one. Therefore, you can follow any one of the three methods, and I am following this method. Oxidation potential of anode plus reduction potential of cathode would give you the cell EMF. Do you understand the problem?
Yes, sir.
Sir?
Yeah?
சார் ஆக்சுவலாக போன ப்ராப்ளமில் எனக்கு ஒரு டவுட் சார். ஈக்லிபிரியம் கொடுத்துட்டாங்கல்ல சார், ஈக்லிபிரியம் கான்ஸ்டன்ட் கே. ஸோ நம்ம அதை அந்த ஈக்குவேஷனில் டைரெக்டாக சப்ஸ்டியூட் பண்ணி டெல்டா ஜி கண்டுபிடிச்சி எலக்ட்ரான் கண்டுபிடிச்சிடலாம்ல சார்?
நீ எப்படி பார்த்தாலும் என்ன பண்ற, ஈக்குலிபிரியம் கான்ஸ்டன்ட் கண்டுபிடிக்கிற கொடுத்துருக்கு
10^10 log 10. ஸோ 10 log 10 1. அப்போ 10
10
into
log
அந்த
10 log 10 சரி சொல்லு. ஈக்குவல் டு
-2.303. அதில் அந்த ஆர்டி அந்த ஈக்குவேஷனில் சப்ஸ்டியூட் பண்ணிட்டா டெல்டா ஜி கிடச்சிடும் சார். டெல்டா ஜிக்கு அப்புறம் நம்ம என்எஃப்இஏ இப்படி டிவைட் பைல கொண்டு வந்துட்டா என் கிடச்சிரும்ல சார்?
நான் உனக்கு டெரைவ் பண்ணி போட்டதை பாருமா. டெல்டா ஜியே கண்டுபிடிக்க வேண்டியது இல்லைம்மா. என்ன கொடுத்துருக்கோம்? log of k is equal to, உனக்கு ஃபார்முலா என்ன கொடுத்தேன்? log k is equal to n N naught அதெல்லாம் உள்ள N naught E divided by 0.06 அப்படின்னு.
Yes, sir.
ஆமா, இது டைரக்ட் அந்த N நம்பர் ஆஃப் எலக்ட்ரான்ஸ் நேரடியாக கண்டுபிடிச்சிடலாம்ல. டெல்டா G கண்டுபிடிச்சி பல வழியும் போய் கண்டுபிடிக்கிறதுக்கு நேரடியாக பண்ணலாமே.
Yes, sir. Thank you, sir.
நீ சுத்தி உழைச்சி மூக்க தொடுற, நான் நேரடியாக தொட்டுரு அப்படிங்கிறேன்.
Okay, sir. Thank you.
அண்டர்ஸ்டாண்ட் பண்ணிக்கிட்டியா?
எஸ் சார். ஃபர்ஸ்ட் நான் அப்படிதான் யோசிச்சேன். ஆனா நீங்க டெரைவ் பண்ண உடனே அதை அப்படியே காப்பி பண்ண ஆரம்பிச்சிட்டேன். அப்புறம் தான் சார் உங்கள்கிட்ட கேட்டேன்.
ஓகே ஓகே. எது எப்படி இருக்காங்க, எதுக்கும் கே அண்ட் இ நாட் ரிலேஷன்ஷிப், டைரக்ட் ரிலேஷன்ஷிப் கொண்டு வந்துட்டேன். இப்படி பண்ணுங்க, சுத்தாதீங்க அப்படின்னு சொல்றேன். வேற ஒன்றும் இல்லை.
ஓகே சார். தேங்க்யூ சார்.
ஓகே. And I am going to give one more problem. It is already asked in the CSR examination. And if you understand this one, we can wind up with this session, then go for the next equation. Take down the problem. Take down the problem. Calculate the stability constant. Calculate the stability constant of the complex. Zn NH3 4 times 2 plus. And this problem, whether it is asked in the coordination inorganic or physical chemistry, I don't know. But this question is asked. Formed in the reaction. Zn plus 4NH3 with a reversible arrow forming Zn NH3 4 2 plus. For this reaction, you have to calculate the stability constant. Stability constant means nothing but the equilibrium constant. If you calculate the equilibrium constant, that is called the stability constant. Comma, given Zn bar, Zn NH3 4 times equal to 1.03 volt. And Zn bar, Zn2 plus equal to 0.76 volt. This alone is given. If you want to know K value is equal to, or log K is equal to NFE naught by 0.06. Here the number of electrons involved in the process you should know. E naught should be calculated. Then equilibrium constant can be calculated. Equilibrium constant is nothing but the stability constant. And for this reaction, you have to calculate what is E naught. How would you calculate E naught for this? You can't construct any cell using this equation. You can't construct any cell. Last problem we have constructed a set of a chemical shell, but using this, it is somewhat leading us to confusion. But don't let you into the confusion. Making use of these electrode potential, we can construct the cell. From the cell, we can calculate the cell reaction. And ultimately, you can see that the cell reaction is nothing but this one. Therefore, now you can calculate E naught, then go for the as usual problem, yes, twisted problem. So such type of problem may be asked. Here, simply follow me. Of these two electrode, which is having higher electrode potential, this is the oxidation potential is not. And it is also oxidation potential. These two are like as per our principle, we are converting the given electrode potential in the oxidation potential. Of these two oxidation potential, which electrode is having higher potential? That would be the anode. Therefore, E naught cell is equal to epsilon 0 Zn bar Zn NH3 4 2 plus then other should be the reduction process E naught of I have to change this Zn 2 plus or Zn. Now we are going to, this is the shell we have constructed making use of these two electrodes. You can easily construct this if two electrode potential are. Or if a cell reaction is given, you can construct the cell. But making use of this cell reaction, that is making use of this cell reaction, it is not possible for us to construct a cell. Because in the reactant side, zinc 2 plus is there, and then the product side, Zn NH3 4 times 2 plus is there. But here, for the ammonia, there is no product is equivalent to that. Therefore, I am making use of this one, that is electrode potential. I have given this type 1. Now, shall we write the electrode potential equation, the oxidation. Zinc is converted into zinc NH3 4 times 2 plus. Now balance the species present. 1 zinc, 4 ammonia, therefore add 4 NH3. And then balance the charge. 2 plus is here, therefore you should add 2 electrons. In the product side, 2 electrons are there, therefore it is oxidation potential. Now write down the cathode reaction Zn 2 plus in the reactant side and the product side in the zinc is present. Balance the species Zn, okay, then balance the charge, you should add 2 electrons. And the sum of this one. Here also 2 electrons are released, 2 electrons are consumed, therefore no necessity of multiplying any of the equation. This and this cancel. The zinc and zinc cancel. Now you will be left with zinc 2 plus 4 ammonia, giving Zn NH3 4 times 2 plus. This is a cell reaction is given. Therefore, if you calculate the electrode using this electrode potential, that will be the E naught for this reaction. Zn and Zn NH3 4 is given as 1.03 and Zn 2 plus for Zn. Here is it Zn bar Zn 2 plus, but we are in need of this. Therefore, the same magnitude, but the sign is changed. Therefore, E0 cell is equal to how much? E0 cell is equal to 0.274. Now you have calculated the E cell. Then finally you have to calculate the K value. K value is given as 10 power something, 10 power N E naught by 0.06. N is equal to how many electrons are involved? 2 electrons are involved into 0.27 by 0.06. Divide it. இதை divide பண்ணி போட்டீங்கன்னா now your answer would be very nearer to 10 power 9. This is called the stability constant. Here is a specific common name, equilibrium constant of the cell reaction. But here we call it as the stability constant of the complex. Whether this question is asked in the, but it is asked one time. Yes, yeah. If at all asked just like this. Which one, ma?
90 வருது சார்.
90, yeah.
Yes, sir.
Just சும்மா லைட்டா பெருக்கி போட்டேன். பார்க்குறேன். 6 into 10 power minus 2, 10 power minus 1. இதே அடிச்சுனா 10 power 1, 2 into these 3. This is equal to 0.9 and 10 power 9 தான் வருது எனக்கு. பாருமா, தப்பு பண்ணியிருக்கேன் நான் பாரு. நான் பண்ணியிருக்கேன் நான் பாருமா.
சார் எங்களுக்கும் 9 தான் சார் வருது.
9 தான் சார். 10 to the power 9.
Sorry, sir.
ரைட்டுமா, தட்ஸ் ஆல் ரைட். இது தான் இப்படித்தான் நாம என்ன செய்வோம், அடிச்சு இருக்கோம். ஆனா உன மனசை புண்படுத்தக்கூடாதுங்கிறக்காக 10 power 90 வச்சிருப்பாங்க. நீ ஜோரா அதை டிக் பண்ணிட்டு வந்து சந்தோஷப்பட்டு வெளியே வந்த அப்புறம் கொஞ்சம் கஷ்டப்பட இருக்கும். அதனால be careful. Okay. Now you understand the problem, I think so. Okay. And take down the question as a homework and make the problem. Set up the electrochemical shell. Set up the electrochemical shell for the reaction 2Fe3 plus aqueous plus SN2 plus aqueous giving 2Fe2 plus aqueous plus SN4 plus aqueous. Is it? I think it is possible for you to set up the electrochemical cell. That is, E naught cell is equal to R, or you can set up and say other setup. Now you have to represent this. I will tell you how to represent it. And calculate the equilibrium constant for the reaction given E naught of Fe2 plus or Fe3 plus is equal to minus 0.77 volt, and E naught Sn2 plus for Sn4 plus is equal to minus 1.5 volt. Now you can calculate E naught of the cell. இதுக்கு தான் equilibrium constant கட்டுறாங்க. Epsilon of the anode and the reduction potential of the cathode, which is acting as the anode, which is acting as the cathode. You can make use of the equation, or here two electrode potentials are given. You can also making use of this one. Here, these electrode potentials given are the oxidation potential value. Arrange them in the air, increasing oxidation potential value. The thin Sn2 plus bar is having higher oxidation potential because it is going in the negative direction. And therefore, it will be definitely acting as the anode. Or you can look into this, iron 3 plus is converted to iron 2 plus. It is a reduction which is taking place in the cathode. Therefore, it is a cathode, and Sn2 plus to Sn4 plus, it is the anode. How many electrons are involved? Take any oxidant, Sn2 plus to Sn4 plus 2 electrons are involved. Or you can take the reductant, total number of oxidation state is 6 plus, and the total number of oxidation is plus 4. Therefore, how many electrons are involved? 2 electrons are involved. And now I am going to write this cell calculation. Sn2 plus for Sn4 plus, that is oxidation potential, anode. In the case of cathode, reduction is taking place. I am in need of reduction potential value. Reduction is iron 3 plus bar iron 2 plus. Given Sn2 plus is this one, and this is this one. Therefore, now you understand the problem. Then work out the remaining problem. Okay. With this, I finish this application with the standard condition. Now I am going to, if it is in the non-standard condition, delta G, delta S, if at all asked, how to approach the problem, sir, and for which a Nernst equation is there. If you want to calculate E for a shell instead of E naught, if you want to calculate epsilon instead of epsilon of the electrode potential for both cases, we are going to use the Nernst equation. And the Nernst equation gives a relationship between the electrode potential and the standard condition, and the electrode potential in the non-standard condition, and the concentration of the electrolytes and the temperature. அப்போ Nernst equation எதெல்லாம் relate பண்ணுது? The electrode potential in the standard condition, that is epsilon naught, and the electrode potential in the non-standard condition, epsilon. Then where another, the concentration of the electrolyte in non-standard condition, the concentration of the electrolyte would be changed. That is, therefore, we call it as a non-standard condition. And no non-standard condition, the temperature is also changed. Therefore, All these four parameters are related by the Nernst equation. Not only for this, but also you are having the relationship between E and E naught. The cell EMF is also related by this one, by the Nernst equation. And what is the Nernst equation? And how we arrive at this Nernst equation? I think you know the Nernst equation. Is it necessary for the derivation of Nernst equation, or shall I, taking it to be granted you have derived this and you all know this one? Tell me quickly. I have to derive, or straight away we will give the net final equation, because we are going to use the final equations only for further calculation, not this one. Therefore, I think it is sufficient to take the Nernst equation, the final derived form. Tell me.
Final equation only.
Final
Okay, sir.
equation, sir.
Okay, thank you very much. The final equation, E epsilon is equal to epsilon naught minus 2.303 into RT by NF into log of the activity of the products. The cell reaction la products இருக்கும் பாத்தீங்களா, அதுல simply I will tell is activity of the products P by activity of the reactants R. Activity of the products by activity of the reactants. This we call it as the log Q அப்படின்னு சொல்லுவோம். What is Q? Reaction quotient. Q for quotient. Quotient of what? Activities. Quotient of activities. For example, A 2 plus 2B minus giving A plus 2B 2B naught. Let us assume this is a cell reaction. Write down the Nernst equation for the cell reaction for the electrode potential or cell EMF. For electrode potential, if you want, E is equal to epsilon. It is a cell reaction. Therefore, epsilon should not be written. You should write it as a cell EMF. E is equal to E naught minus 2.303 into RT by NF into log of activity of the products. What are these products present? That is, என்னெல்லாம் இருக்கு? Activity of A into activity of B whole square divided by activity of A2 plus into activity of B minus square. This activity of the products divided by activity of the reactant, we call it as the quotient of the reaction activities. Quotient of the activities, reaction quotient, we will call it this. And you may come across this type of problems in the equilibrium constant. Here also you are giving the concentration of the reactant by the concentration of product by concentration of the reactant, you are saying. But here there is one difference is that there the concentration is the concentration of the product existing at equilibrium. But here the quotient calculation, the concentration or the activity here we are going to substitute is not the equilibrium constant. The concentration at the time of investigation. நம்ம என்ன டைம்ல கால்குலேட் பண்ண போறாங்களோ அந்த டைம்ல இருக்கிற கான்சன்ட்ரேஷன் we are going to substitute. There is a difference. Therefore, we won't call it as the equilibrium constant. We will call it as the reaction quotient. That is the difference. Quotient means here the concentration should be given in terms of the concentration at a particular time, not the equilibrium constant. That's the difference. Therefore, next step is activities, but here the activities of any solid or pure liquid. You might have studied the activity of a solid or a pure liquid. is equal to 1, the activity of the ion would be going on changing. Therefore, if at all it is occurring, it is a pure liquid or pure solid, their activity would be 1. You should furnish the activity of the A2 plus and the ions only you have to furnish. And the activity in certain gases, the activity is nothing but the activity coefficient and its concentration. Activity coefficient of the cation and activity coefficient and concentration of the cation. This is called A plus. And activity of the anion is given by activity coefficient of the anion into its concentration. You might study. When the solution is very dilute, the activity coefficient gamma is taken to be 1. Under this condition, the activity is more or less equivalent to the concentration. When we will be equating the concentration to the activity when the solution is very dilute. That is, as dilution increases, the electrolyte will be behaving ideally. As concentration increases, it behaves non-ideal. And the ideal solution activity. You might have studied this one. Therefore, we take the solution concentration to be small. Therefore, instead of activity, we are making use of the concentration. Hereafter, we are going to use the Nernst equation in terms of the concentration, not in terms of the activity. If solid and pure liquids are there, put their concentration to be activity should be 1. Therefore, they would not be generally taken into account for the calculation. Okay. And when will you write the Nernst equation in the form of epsilon to epsilon naught for the electrode? For the electrode, how can I say that one equation is given? How can I say where I have to write the relationship between epsilon to epsilon naught or E and E naught? I have told you, look at the cell reaction given. If it is not involving electron in either side, then definitely say that this is a cell reaction. Under this condition, you write the Nernst equation as E is equal to E naught minus 2.303 RT by NL. And the standard condition, T is equal to 298, R is equal to 8.34, F is equal to this much. Therefore, this is reduced into E naught minus 0.059, or for our purpose, I will take it as this one into log into concentration of the products by concentration of the reactant. Therefore, we are going to use finally this form only. We are simplifying this one, keeping it in your mind to work out the problems. And now, making use of this, you can also write for the cell electrodes and so on. Is not for the cell electrode how to write down this one. I will give one example and you can easily follow this one. Suppose you are given a M giving M of N plus N number of electrons. Write down the Nernst equation for this. This equation represents this electrode reaction, not a net reaction because it involves the electron as the product side. Therefore, in such cases, you can write epsilon is equal to epsilon naught minus point, I'm sorry, point not 6 by n number of electrons involved in the process into the log of activity, not activity, the concentration of m of n plus. In the here the electron is taken to be equivalent to that activity is remaining the same. There is no ideal electron, non-ideal electron. Therefore, its activity is equal to 1 divided by the activity of m. M is a solid, therefore the activity is taken to be 1. Therefore, if you cancel this, now the Nernst equation can be written as 0.06 by n into log of the concentration of the electrolyte. If the concentration of the electrolyte is 1 molar, put log so equal to 1. Log of 1 is 0, and this is equal to 0. Now epsilon would be equal to epsilon naught. That is standard potential. Therefore, when will be the E value, epsilon would be equivalent to epsilon naught, and the activity or concentration is, or when the quotient is equal to 1. Therefore, you can make use of this reactant concentration, product concentration. Therefore, what about the quotient value? Therefore, what about the E value or epsilon value? Now, here I have given for the cell reaction. If the reactant is 1 molar, the reactant concentration 1 molar, product concentration is 1 molar, product concentration is 1 molar, then product concentration divided by reactant concentration quotient is also 1. If quotient is 1, log of 1 is equal to 0. Now E is equivalent to E naught. E is equal to E naught. When the reactant concentration is higher concentration and the product concentration is lower, then the quotient value is greater than 1, is not. The quotient value is greater. The quotient value is greater than 1 means log value is positive. You know this, log value is positive. If log value is positive, this value would be negative, and the E value would be less than E naught. Less than E naught. On the other hand, if the reactant concentration is lower concentration and the product is the higher concentration, because the quotient is concentration of the product divided by the concentration of the reactant. Therefore, the quotient value is தப்பா போட்டிருக்கேனோ. Yes, I have made a mistake here. Higher and lower reactant concentration is higher means the quotient value is not greater than 1. Sorry. It's less than 1. If it is less than 1, log of less than 1 would be negative value. That negative and this negative converts into plus value, and the E value is greater than E naught. On the other hand, reactant concentration is lower and product concentration is higher, then the quotient value is greater than when in such condition epsilon E value is less than E naught. These are the three conditions. If you evaluate this is looking into the concentration of the reactant and product, what about the relationship between the E and E naught, whether it will be equal or less than or greater than? Simply seeing the concentration, you can come to the conclusion the E value, that is the cell EMF under non-ideal condition, sorry, non-standard condition, whether it is equivalent or non-equivalent to the ideal situation, that can be done. That's why I am giving this you for this one. Okay. And another important thing is the temperature. Here the temperature, we assume that it is a constant, that is standard condition, 25 degree. Therefore, we brought that temperature into the constant. Suppose what happened to this E value as temperature increases? Anybody may ask that one. Once again, Nernst equation, in such cases, you should not merge this T with this constant. There will be some other method. Here, but I think so far the relationship, graphical representation of this cell, sorry, Nernst equation is asked, I think so. Here also I am going to represent the Nernst equation in terms of a graph, for which we will go by step. And finally, I will give you the one tabular column. Looking into the tabular column, you can say what happened to the reduction potential as the temperature increases, or what happened to the reduction potential as the concentration increases, and so on. You can easily tell this value immediately for the electrode potential. The relationship is for the electrode potential. Because making use of this nasty graphical diagram, one time one problem has been asked in the 4-mark question, I think so. Electrode potential. First, we will consider the electrode potential of the oxidation potential. Then we consider the E for the same for this reduction potential. Then we will draw the graph. The graph looks like what? Then as the concentration increases, what happens? Concentration decreases. What happens? We will easily relate these two. And for the oxidation, let the M is converted into Mn plus Ne. Okay, write down this enhanced equation for this. E is equal, epsilon is equal to epsilon naught by, and we take the temperature constant, therefore 0.06 by number of electrons involved into log of the concentration of Mn plus only. Here this activity is taken to be 1, the activity of the solid electrode is taken to be 1. And under this condition, if you plot here, it is a constant. Number of electrons involved in this given electrode is a constant. Here, the concentration in which the electrode dipped is maybe changed. If the concentration varies, E value would be varying. Therefore, now you can plot two variables are there. One is epsilon, y is equal to this in the form of y is equal to C minus mx in the form, this is the x form. Therefore, if you plot log of the molarity or log of the concentration of the electrolyte here, the minimum value is 0 and the minus value போகலாம் 0 and so on. Minus value, when will this log value is minus? Sometimes it may be going in this side also, because when the concentration value is less than 1 molar, log of minus 0.8 or minus log of 0.8, log of 0.7, a negative value would be there. Therefore, log of 1 is this one. Now, this you plot this one, there is a concept is there, epsilon 0. Therefore, epsilon 0 is nothing but the electrode potential at log of ML is equal to 0. When the log of ML would be equal to 0, log of 1, that is concentration of M plus is 1, it is equal to 0. Therefore, it is not passing through the origin. Some place it is going on. And this one, and what is this? There is a negative value there. Slope is found to be negative. Therefore, what is the actual graph looks like it? The value should be going on decreasing as the concentration increases. Therefore, the graph would be like this. And if you extrapolate it to 0 value, that is nothing but epsilon naught. Therefore, if you see this graph, in the case of E of oxidation potential, oxidation potential என்ன நடக்குது? As the concentration of the electrolyte increases, the oxidation potential value, increases when the concentration of the electrolyte increases, the oxidation potential value decreases. Do you understand this? And what about the reduction potential value? What about the reduction potential value? The E of the reduction potential value is going on increasing, just to reverse. Or I can show it to you. This is for metal or metal ion electrode. What do you want to see this case? E of the reduction potential increases, the concentration increases for the metal electrode. If you want, I can say just reverse the reaction. It is a reduction value, and for which you can write the value as epsilon 0 minus 0.06 by n into log of 1 by concentration of m of n plus. Okay, this is the Nernst equation. This, when you bring this denominator concentration of the electrolyte to the numerator, it will be becoming the inverse minus, that inverse minus, and this would be converted into plus yn into log of concentration of the mn2 plus, concentration m of n plus. Now, what is the difference between this and that? This is minus charge is there. Here, plus is that. If you plot now E versus log of m of n plus 0, here is going on increasing. This is the situation. But it is not passing through the origin because there is a y-intercept, and this is the E0 value. Therefore, in the case of metal electrode, the reduction potential is going on increasing as concentration of the electrolyte increases. And now we can see this electrode potential for a non-electrolyte. For a non-electrolyte, what happens? For a non-electrolyte, we will write this equation as A of n minus is given as A plus n electron. This is the non-electrolyte. Because chloride would be undergoing to chlorine. It is a non-electrolyte. This would be there in such cases. What is the oxidation potential value? What is the reduction potential value? Or this is what is the here oxidation takes place or reduction takes place? Tell me. According to this equation, oxidation takes place or reduction takes place. Hello. Oxidation. Therefore, oxidation potential E ox is equal to epsilon oxidation minus 0.06 by n into log of, here the activity is 1, here the activity is 1, therefore log divided by the concentration of the reactant minus. Or bring this denominator value to the numerator, it be converted into plus 0.06 by n into log of the concentration of A power n minus 1, A of n minus 1. Now, if you plot the E oxidation versus the log of concentration of A n minus non-electrolyte is 0, the value is a positive slope, a straight line with a positive slope, but there is an intercept, therefore it's going on like this. Therefore, E of oxidation increases to the metal electrode. Therefore, what about the E of reduction for the non-electrolyte? It is going on decreasing. And this type of when be tabulated in your tabular column, and it will be very helpful to you if some question arises in this. We will take this anode as the metal bar electrode. Then what happens as concentration increases? As concentration increases. As concentration increases, epsilon oxidation decreases and epsilon reduction value increases. For a non-metals, the value is E of oxidation, epsilon of oxidation is going on increasing, and the reduction rate is going on decreasing. Keep it in any one of it in your mind, the other would be just reverse to this. Okay. Similarly, you can derive the equation. What happened to the potential as the temperature increases? In such cases, we are going to plot, the equation would be rearranged and we will plot the epsilon versus the temperature. Here also, if as temperature increases, in the case of metal electrode as the anode, E of oxidation is going on decreasing as in this case also. And E of reduction goes on increases. Therefore, whether concentration increases or temperature increases, concentration increases or temperature increases, for the metal electrode as the anode இருந்தால் oxidation decreases and the reduction value increases. And for the non-metals, the oxidation value increases and the E of reduction value decreases. This and this remains the same. Therefore, I have placed as concentration or temperature increases. This is the situation. And you may be asked which of the following statement is the correct statement. A metal is acting as an anode. Then which of the following statement is correct? Both oxidation potential decreases in as the concentration increases and temperature increases, or concentration increases, temperature decreases. இப்படின்னு போட்டு உங்களை கன்ஃபியூஸ் பண்ணுவாங்க. But keep it in your mind. And using this, you can calculate, you can tell that answer for this question. Now we will see one or two numerical problem in this section. And if you see this numerical problem in this section, we will go for the next application of this electrode potential. We will take one or two numerical problems because all other problems will be one and the same. Take down the problem. Calculate the EMF at 298 Kelvin generated by the voltaic cell. Generated by the voltaic cell, in which the reaction is Cr2O7 2 minus aqueous plus 14 H plus aqueous plus 6 iodide aqueous giving 2 chromium 3 plus aqueous plus 3 iodine solid plus 7 H2O liquid. When the dichromate concentration Cr2O7 2 minus concentration is 2 molar, H plus concentration is equal to 1 molar, iodide concentration is equal to iodide concentration is equal to 1 molar, and chromium 3 plus concentration is equal to 1 into 10 power minus 5 molar. And looking into this concentration, you can tell that the condition is a standard condition or not. Temperature is 298 degree Kelvin. Okay, temperature is the standard condition. The electrolyte concentration H plus and I minus is a standard condition. But the dichromate and the chromium 3 plus concentration is a not standard condition. Therefore, this is a cell under non-standard condition. If you measure, 1 minute, course not class like okay, all right. If you measure the cell potential, this potential is not E naught, it is called as E. Therefore, this E can be calculated. How you can calculate E? Provided if you know the E naught. The E naught for the cell, here they may give this E naught for the cell directly as E0, or they will give you the electrode potential, oxidation electrode potential and reduction electrode potential. You have to calculate the E naught of the cell. If they give it directly, then it is a direct problem. Instead giving E cell, E naught cell directly, they are giving the electrode potential. It is a two-step problem. You have to calculate the E naught. In this problem, after this concentration of the chromium, E naught of the cell is equal to 0.79 volt. Therefore, calculate the EMF they're not any. You can say whether it is you are calculating this E, whether it is a E naught or E, it is E because it is in the non-ideal condition. What is the Nernst equation for this? E is equal to E naught minus 0.06. Why we are putting is 0.06? Because temperature is 298 standard condition, 0.06 divided by n into log of. Now we are going to write down the concentration for which term we have to write down the concentration for which we should not write down the concentration. Log of the concentration of the products, Cp, by the concentration of the reactants. We will write the next step. E naught is given as 0.79 minus 0.06. How many electrons are involved in the process? N is required. How you can calculate? Either you can take dichromate or you can take iodide and you can find out how many oxidation states are there in the reactant side. For one iodine is 1 minus or 6, it is minus 6. In the reactant product side, iodine is in the elemental state. It is 0, 3 into 0, 0. Therefore, total number of electrons involved in the process is 6. Therefore, 6 into log of concentration of the product. Here, for whichever would be the concentration, chromium 3 plus. Here, the chromium 3 plus concentration is given as this one. Therefore, you write it in 1 into 10 power minus 5 into power 2. Why? Because 2 chromiums are there. You write down the equilibrium constant equation, concentration power. Right? And into any other products, iodine is the product, but it is in the solid state. Its activity is equal to 1. Therefore, concentration activity is also taken to be 1. And water, pure liquid is present. Once again, pure liquid or this solid state, we will take the activity 1. Therefore, no concentration term is available in the product side divided by the reactant side. Here it is an electrolyte, it is an electrolyte. Electrolyte, you should use the concentrations. And what is the concentration given for the dichromate? 2 into what is the concentration given for the hydrogen? 1 power 40. And what is the concentration of iodine? 1 power 6. Therefore, now it is equal to 0.79 minus 0.01 into log of. This 2 can be also brought before this into 2. அப்படின்னே கூட நீங்க போட்டுக்கிடலாம். Into 2 into log of 1 into 10 power minus 5 by 2. This is the simplified equation. How you will take this outside log of 1 into 10 power minus 5. இது வந்து எப்படி எழுதலாம்? Log of A by B can be written as log A minus log B minus log 2. Okay, you understand how to calculate this one. And this is written as log of 1 plus log of 10 power minus 5 minus log 2. Log of 1 is equal to 0. Log of 10 power minus 5 is equal to minus 5 into log of minus 2 minus 0.30. Therefore, it is 0.53. Therefore, 0.79 minus 0.02 into minus 5.3. 5.3 into 2, 6, 10. Here 2 decimal, here 1 decimal, therefore this one. Minus into minus plus, therefore equal to 0.79 plus 0.106. Therefore equal to, the correct answer is 0.896. Therefore, the E value and the non-standard condition is this much. This is the way you can calculate this E value. Do you follow this? Okay, shall we? Any doubt is here? Here you should be very cautious in solving these log values. Very cautious. Take it outside, then solve and then bring it to side. Otherwise, it will confuse you to lead to a different value. Okay, take down the problem as homework. Consider the voltaic cell. Consider the voltaic cell, whose overall reaction is Pb2 plus aqueous plus zinc solid giving lead solid plus zinc aqueous, zinc 2 plus aqueous. What is the EMF generated by this voltaic cell? When the ion concentrations are lead 2 plus is equal to 1.5 into 10 power minus 3 molar. Zn2 plus is equal to 0.55 molar, comma, E of E naught, epsilon naught of zinc 2 plus for zinc is equal to minus 0.76 volt, and epsilon naught of lead 2 plus is equal to 0.126 volt. Option A, 0.71 volt, and temperature is not given. அதில் எழுதிக்கோங்க, calculate. என்ன எழுதிருக்கீங்க? What is the EMF generated by this voltaic cell at 298 degree Kelvin? Temperature is not given, included. If at all, if temperature is not given, take it to be the standard state temperature. Okay, 0.71 volt, B, 0.56 volt, C, 0.49 volt, D, 0.79 volt. Be careful. First construct, you have to construct the கண்டுபிடிக்கணும். E naught should be calculated, because you are asked to calculate E. It is not an electrode, it is a reaction. So for E is asked, you should calculate E naught. E naught is not directly given. You have given in the electrode potential how to make use of this electrode, which is the anode, which is the cathode. Don't take this value as a from the equation. The equation, you know, from the equation, you take it as which is the cathode, which is the anode. அதை பார்த்து கண்டுபிடிங்க. Which is the cathode here? Which is the anode here from the equation? Tell me.
Zinc, sir.
Zinc bar. And அதுக்கு you should have an oxidation potential. But given is the reduction potential. You have to change this one. Which is acting as the cathode here? Lead 2 plus bar lead. For which potential is required? Reduction potential is required. But given is the oxidation potential. Therefore, change into the reduction potential. Find out the E naught of the cell, substitute minus point is the temperature in the standard state by n number of electrons involved in the process. Looking into this, you can immediately tell the number of electrons involved in the process. How many electrons?
2 electrons.
2 electrons. Then into log of concentration of the products. Which concentration alone you would take into consideration for problem? Zinc 2 plus alone. Lead the sulfur, lead the solid state. It is the solid state, therefore activity is 1. Don't consider about that one. Similarly, in the reactant side, you have to consider the concentration of the lead 2 plus. Here, the concentration of lead 2 plus is lower and it is zinc 2 plus is higher. Therefore, E naught value would be எப்படி இருக்கும்னு எதிர்பார்க்குறீங்க? E naught value would be higher than this one or lower than the standard value. அப்படிங்கிறத பார்த்த மாத்திரத்துல சொல்லிடுவீங்க. நீங்களே பாருங்க ஹையரா இருக்குமா லோயரா இருக்குமா. Because the log value upper is higher, lower, therefore log quotient would be greater than 1, quotient value is greater than 1 இருந்தால் E value is less than E naught. Less than அப்ப அதை பார்த்து E0 value greater value இருக்கிறதெல்லாம் நீங்க கேன்சல் பண்ணிடலாம். What is the E0 value பார்த்தீங்கன்னா just reverse this and you will get E0 value is equal to point மாத்தி போட்டா என்ன கிடைக்குது 0.634 I think so. Therefore E value should be less than 0.634. Therefore which answers are not possible? A is not possible, D is not possible. Either B and C would be the correct answer. Okay. Then one more problem for the exercise, and with that problem, but the 2 problems are there, and the 2 problem தர்றேன். How you are working out that problem? It may be appearing in the next CSR examination. If the potential of, take down the problem. If the potential of zinc H plus shell is 0.45 volt at 25 degrees centigrade, when concentration of zinc 2 plus is equal to 1 molar and pressure of hydrogen is equal to 1 atmosphere. Here in the case of gaseous state, the pressure, instead of the concentration, use the pressure as the concentration. Come on. What is the pH of cathode solution? What is the pH of the cathode solution? Option A, 2.6, B, 5.2, C, 3, this one, 7.8, D, 4. Find out the correct answer. Next problem. Consider the voltaic cell, where anode half reaction is zinc solid giving zinc 2 plus aqueous plus 2 electron, and the cathode half reaction is SN2 plus aqueous plus 2 electron, giving tin solid. What is the concentration of SN2 plus? If Zn2 plus concentration is 2.5 into 10 power minus 3 molar, and the cell EMF is 66 volt, and E naught is equal to 0.62. But this 0.66 volt is the non-ideal condition, that is E. Option A, 3.3 into 10 power minus 2 molar. B, 1.9 into 10 power minus 4 molar. C, 9 into 10 power minus 3 molar. D, 6.9 into 10 power minus 4 molar. And E, 7.6 into 10 power minus 3 molar. This type of problem so far not asked, but it is a little bit difficult problem. But if you work with this type of problem and make it easier, then all other problem compared to this problem will be very, very easier. Therefore, workout is such a difficult problem also. Okay, with this we finish the third application and then the last application of the electrode potential are going to see is to identify the stability of the oxidation system. Sorry, not that is application. To calculate, the next problem is to calculate the oxidation potential or the electrode potential of some metals. If electrode potential of the metals in two different oxidation states are given. To calculate the electrode potential of the some metals, say some metal in one oxidation state, calculation of the electrode potential in one oxidation state of the metal, if the oxidation potential of two other oxidation state of the metal is given. For example, take down problem, we will work out it. Given thallium for thallium plus E of this epsilon as this is equal to 0.336, whether it is a standard condition or in the non-standard condition, whatever may be this, you apply this problem. Epsilon of thallium for thallium plus is equal to 0.336, and the electrode potential of thallium plus for thallium 3 plus is equal to minus 1.25 volt. Find out the potential of thallium bar thallium 3 plus. Here look out, thallium to thallium plus, one oxidation state. Thallium plus 2, thallium 3 plus oxidation state, that is second electrode potential is given. You are asked to calculate the potential for electrode potential for a third type one is there. Here the oxidation state of the same metal is going on changing. How to make use of it? Very, very simple if you follow this one. Here first consider in this case, in which case the highest oxidation state and lowest oxidation state of the metal is given. First to find out the lowest oxidation state of the metal is 0, then +1, +1, +3, and +3. And the highest is given as +3. And take this as the electrode in the left hand side, T epsilon of TL bar TL 3 plus. This electrode potential definitely would be equal to What are the other two oxidation state given? +1 and +3. Therefore, write down in the left-hand side, it is equivalent to epsilon of the take down the reactant as such TL for the lowest oxidation state. TL plus epsilon of next the TL plus is there, it should be cancelled like that. Therefore, take the TL plus in the upper side divided by which is the product TL3 plus. Now we have written the relationship between these two electrodes and these two electrodes by this way. By this way. I will give you another problem and you can give it. Once you establish this relationship, then the problem is solved. Therefore, given the 3 electrode or 4 electrode, even 5 electrode potentials are given, you may be asked to calculate for a 6th electrode potential. Just arrange them. What is the relationship between them? For which the highest and the lowest oxidation number electrode is taken in the left hand side, and other electrodes are written in the other side. And what is the relationship between them? That is the delta G0 taken place in or delta G, free energy change for the net reaction, delta G is equal to the free energy change in this reaction, delta G1, plus the free energy changes in this. That is whether a reaction takes place directly TL to TL plus, or it takes place in steps TL to TL plus first, then TL plus to TL3 plus, second stage. Whether the reaction takes place in one step or 2 steps or 3 steps, the net change, free energy change is equal to, say, 1 Haber cycle of the one purchasing leg. Based upon this, we are doing this calculation. But the delta G is equal to NF E, and it is equal to NF E1. For this, we put it as NF E1, and this is equal to NF E2, which is constant in both sides, minus, sorry. And they cancel the minus in both sides, and F on both sides. N of E is equal to N1 N1 area N2, because number of electrons involved in the process would be different. N1 F E1 plus N2 E2. இதே மாதிரி E2. If 4 or 5 electrodes are given, simply writing is N3 E3 plus N4 E4 and so on. That's the methodology. Here, this is the relationship. Of this relationship, if these two electrode potentials are given, you can calculate the electrode potential for this. Or this and this are given, you can calculate the electrode potential of these. Therefore, whatever electrode potential, you can easily calculate this one. And this is the methodology. First, write down the left-hand side, the lowest to highest oxidation state. Then all other electrode potentials given are arranged accordingly. You will easily get this. Now we will work out the problem. Here, what is the relationship? Looking into the problem, you can easily say, sir, this is the relation I have to write, and for this is I am going to calculate. Now I am going to give a training into this. Here, these two electrodes are given, and this is asked. I am seeing this given electrodes. What is the minimum electrode oxidation number of that electrode metal, and what is the maximum oxidation number involved? I am looking into this. Immediately, I am writing the relationship. E of TL bar TL 3 plus is should be equal to epsilon of TL bar TL plus and TL bar by TL plus bar TL 3 plus. Then what is the relationship? N into E is equal to, this is the first electrode, therefore N1 into E1 This is the second electrode, N2 into E2 and so on. Only 2 electrodes are given. Here, what is asked? Calculate E for this electrode potential. I'm sorry, epsilon. Sorry. Put it as the epsilon, not E. Epsilon. We are asked to calculate epsilon. Okay. What is N? N is the number of electrons involved in the process. Now, what is the number of electrons involved in the process? Looking into the reactant products, 3 electrons are involved. Therefore, 3 into epsilon is equal to, here N1, this one, how many electrons are involved? 1 electron. What is the E1? 0.336 plus how many electrons are involved? 2 electrons into value is given minus 1.25. Sometimes the value may be given in the inverse manner. Here oxidation potentials are given. Sometimes they may give a reduction potential value. You have to change accordingly. Whether the relationship is correct or not, you check it before going to work out. Before going to work out, you check it out. How to check it out? How many electrons in the left-hand side? 3 electrons. In the right-hand side, how many electrons are there? 3 electrons. Okay. Now we are correct. Then proceed. It is equal to 0.336 minus 2 into this one, say 2.5, and this is equal to 3 epsilon. Epsilon is equal to 0.3336 minus 2.5 by 3 equal to nearly 0.7 something will be there.
721, sir.
322, 7.3, nearly 7.2 or 3 would be there. Correct answer and then paathukiringalappa?
Yes, sir.
Okay. If you are following this, take down the problem, and 2 more types are there. That the problem we will give, finish this today's session. Then one more application, we will see it tomorrow. Take down the problem. The standard electrode potential, epsilon naught of Fe3 plus for Fe2 plus and Fe2 plus bar Fe are 0.77 and minus 0.44 volt respectively at 300 degree Kelvin. That is correct or solumna 298 degree Kelvin. The epsilon naught of Fe3 plus for Fe. Fe3 plus for Fe electrode at the same temperature is A 1.21 volt, B 0.33 volt, C minus 0.11 volt, D minus 0.04 volt. Here, what is asked? Iron 3 plus for iron. Before seeing this, I am looking into the what is the minimum oxidation state, what is the maximum oxidation state. Here, the potentials given are all reduction potential values are given. Therefore, we can write down the relationship, all the electrode potential, reduction potential value. If they are all giving oxidation potential value, write down in the oxidation potential value, the same relation. No change would be there. Sometimes the reduction potential value as well as oxidation potential are mixed together. You convert either to oxidation or reduction. You keep them all in the same potential manner. That is the main important thing. Here they are asking this value. The reduction potential value is here. Minimum oxidation potential is 0 and maximum is +3. Intermediate state is a +2. Therefore, we keep it as the reduction potential value. E naught of Fe3 plus bar, Fe equal to, how you can write this equation? E naught of Fe3 மேல இருக்கணும். அப்படி இருக்கிற potential, கீழே அதுக்கு அடுத்த potential, அடுத்த oxidation state, Fe2 plus அடுத்தது next Fe2 plus in the upper side, in the reactant side, for the lowest is 0. This is the relationship we have constructed. Once you construct, and you can check it up, this Fe2 plus and this Fe2 plus cancel, and Fe3 plus for Fe. Here also Fe3. Okay, I have written correctly. அப்படியும் check பண்ணலாம். If anything, if in the case of 4 or 5 electrode potentials are given in the right hand side, sometimes you may be omitting some other electrode potential. Therefore, in this way, whether it is a correct thing, okay, everything correct, then the relationship is Valakambola n of E naught is equal to n1 E naught 1 plus n2 E naught 2. And you work it accordingly. Next type problem, take down the next type problem. Given the Latimer EMF diagram, 2.2 volt, Fe3 plus, giving 0.77 volt, iron 2 plus, giving iron, and this is what is it? Value is 1.08 volt. What is this? Find out the value for this electrode potential. And how to write down the relationship. It is the minimum oxidation state of the metal given 0. And it is 2 plus, 3 plus. And what is the oxidation state of iron here? What is the oxidation of iron here? 6. Therefore, we have to start 6 and ending with the 0. Generally, Latimer diagram is given only in terms of the reduction potential. The highest oxidation state in the left-hand side and the lowest oxidation state of the given metal would be in the right-hand side. All Latimer diagram, this electrode potential diagram would be remaining as such. And the 2.2 volt, what is that? When FeO4 2 minus, that is plus 3 state to plus 6 state to plus 3 state conversion, 2.2 volt potential, reduction potential is available. What do you mean by 0.77 volt? When Fe3 plus is converted into Fe2 plus, 0.77 volt is there. What is this question mark? When iron 2 plus is converted to iron, what is the reduction potential that is asked? What is the maximum here? I'm going to write in this like this. Iron is in the plus 6 state in the left hand side, FeO4 2 minus bar, the minimum potential is 0. Therefore, Fe, it should be equal to, start with this, FeO4 2 minus. Next it is plus 6 state. Next state below the plus 6 state is plus 3 state. Look here, plus 3 state. Therefore, I am writing is just like this. I have 3 plus. Plus, I am going to write is, here the below iron 3 plus should be cancelled. Therefore, I am writing in the upper side bar, and next below the iron, next to iron 3 plus is the iron 2 plus. Therefore, below you write it as Fe2 plus. And next you have to write the lower Fe2 plus should be cancelled as, and the next oxidation state is 0. Now, for which electrode potential you are asked to calculate? This one, that you know. For other, it should be given, then only you can calculate. For this overall, it is having. Now, what is the oxidation number changing between this and this? 6 into the reduction potential value is 1.08 is equal to, next, FeO4 2 minus bar Fe3 plus. That is nothing but they are asking this one. Therefore, what is the change in the oxidation number? It is 6 plus to 2 plus. Therefore, 3 number of electrons involved. 3 into, what is the voltage? 2.2. plus how many electrons are involved in the process? 1 electron into the voltage, the voltage 0.77 plus how many electrons are involved? 2 electrons. What is the voltage? That is asked. Now you have arrived at the relationship. Whether correct relationship or not. How many electrons are there? 6 electrons. The right hand side 3, 1, 4 plus 2, 6. Okay, right? Then proceed. What is the value of S? You can be given any number of these or any number of, for example, instead of giving this, instead of asking this one, you may be asked to calculate what is the value of this one. Here this is given as minus 0.45 volt. What is the value of this one? This is the basic procedure you should adopt. Then the next last type of this problem, take down the problem. The epsilon naught of Fe3 plus for Fe2 plus Fe is equal to Fe3 plus for Fe is equal to X volt. Fe2 plus for F is equal to X, the X1 volt, this is X2 volt. Then find the epsilon for Fe2 plus for Fe2 plus. Find the answer. What is the answer? Answer is, answer is A, X3 plus 2X2, sorry, X1 plus 2X2, B, X1 minus 2X2, sorry, first A, X1 plus 2X2, B, X1 minus 2X2, C, 3X1 minus 2X2, D, 3X1 plus 2X2, which is the correct answer. Work it out. And any doubt? Shall I wind up the session?
Yes, sir.